Welcome. This video is going to take a closer look at atomic structure, specifically how you can use the information on the periodic table to figure out what element you're dealing with, how many protons, neutrons, and electrons that element happens to have. So on this first slide, you see there's a symbol taken from the periodic table for carbon, and there's a number 6 at the top, and then there's a number with several decimals on the bottom. There's also the symbol and then the name. So the symbol is a 1 or 2 letter abbreviation. The name is the same in any language. The numbers are going to be the same in any language, although they can be written different if you have a Chinese or Japanese or another country's periodic table. But the atomic number is the whole number generally given at the top of the square, and it's equal to the number of protons in the nucleus. And since the atom has to be neutral, it's also equal to the number of electrons in the electron cloud. So the atomic number is a big deal because it tells us what element we're dealing with. All elements of carbon have to have 6 protons, and since they're neutral atoms, they'll have 6 electrons as well. The atomic mass at the bottom is a decimal because it's an average. In fact, it's what we call the weighted average. And sometimes people refer to it as the average atomic mass because it's a weighted average of all the isotopes or all the possible atoms of carbon. Remember, some carbon atoms can weigh a little more or a little less than the average number. So rounding the atomic mass to the nearest whole number will tell you the mass number of the most common isotope. So in the case of carbon, 12 is the most common isotope. And then the mass number is the sum of the numbers of protons and neutrons in a specific isotope or in a specific atom. And the mass number doesn't actually appear on the periodic table because you'd have to know exactly which isotope or atom you're dealing with. So instead, we just see the average of all those mass numbers on the periodic table itself. So how many protons and electrons are in gallium and molybdenum? So the first thing you need to do to be able to complete this is you need to find out where these two are located on the periodic table, and knowing their symbols would be a big help. Now gallium is easy because its symbol is pretty much what you would expect. It has the symbol Ga. Now when you find gallium, it's sort of off to the right. It's over in family 3, about midway down. And you see it has an atomic number of 31 up on the top. So there are 31 protons and 31 electrons in gallium. And you notice I'm abbreviating proton with a P plus and electron is an E minus. That just reminds us of the charge on each of those particles. Molybdenum is a little tougher to find. And as you look around, sort of in the middle of the table, you will find MO, and that's the symbol for molybdenum. And you'll see its number is 42, so I know it has 42 protons, and that means it also has 42 electrons. Second question says, what's the atomic number of an atom that contains 37 electrons? Well, if it has 37 electrons, then I can assume it also has 37 protons. And so 37 is its atomic number. So this is a little easier to find on the chart. I go to number 37 and I see it's something with the symbol Rb, or rubidium is its name. And then number 3, what is the atomic number of an atom that contains 72 protons? I go right to that square for 72. I find HF, or something called hafnium. And that's a start to using the squares on the periodic table to look at protons and electrons. The next thing is to look at the neutrons. And when we talk about neutrons, we have to talk about something called an isotope. And isotopes are atoms of the same element with the same number of protons, but different numbers of neutrons. So that means if they have the same number of protons, they're still going to have the same number of electrons. But the only thing that's different is they have a few more or a few less neutrons, so they're a little heavier or a little lighter. So changing the number of neutrons only changes the mass number or the weight for that atom only. So if we take a look at some examples here, the mass number represents the sum of protons and neutrons for an atom. You might remember that back from the first slide. It isn't shown on the periodic table because it varies for different isotopes or different atoms of the same element. The mass number is not an average like the atomic mass. It's talking about just one specific atom or isotope. And there's two ways to show an isotope, or what they call isotopic notation. You can give the mass number after the element's name, like hydrogen 3 or hydrogen 1. And in this case, you'd have to look up the atomic number, but since you know what the element is, that's not real difficult to do. The other thing they do is they stack the mass number over the atomic number to the left of the symbol. So mass number on top, 3 for hydrogen 3, and then the atomic number for hydrogen is always 1, so that's on the bottom. So these are the two ways to show you have an isotope and which isotope you have. So now when we do this try, it says an isotope of copper contains 29 protons, 29 electrons, and 36 neutrons. What's the mass number? Well, mass number is always your protons plus your neutrons. So in this case, it's 29 plus 36. We really didn't need to know there's 29 electrons. And when I add those up, I get a mass number of 65. Number 2 says how many protons, electrons, and neutrons do uranium-235 and uranium-232 each contain? Well, uranium, if you look it up, always contains 92 protons because that's its atomic number. And atomic numbers for an element do not change. So 235, if I subtract the 92, 235 has 143 neutrons, and we know it has 92 protons and 92 electrons because it's uranium. Uranium-232 then is still going to have 92 protons and 92 electrons, but now when I do the subtraction, I see it only has 140 neutrons. But again, it still has the 92 protons and the 92 electrons because it's uranium.